let's find the values of x which satisfy this inequality. First things first, we've got a quadratic in terms of x squared. We've got x to the 4, x squared, and this is x to the 0. So let's replace x squared with a y. So we'll let y equal x squared. And therefore what we have is y squared is less than 8y plus 9. And we can rearrange this so that we have 0 on one side. And we'll actually solve it equals. So as an equation instead of identity. This will give us kind of the boundary points. So the points of intersection between the two curves. And from there we can inspect whether we need to be inside those regions or outside them. So spot on. Let's solve then. We're going to have y squared minus 8y minus 9 is equal to 0. And what we're going to get then is y minus 4 squared minus 4 squared minus 9 is equal to 0. And then if we evaluate this number over here, what we have is that y minus 4 squared is equal to, well, the 4 squared, 16. This is a 9. So altogether that gives us 25. So let's square root both sides. We get y minus 4 is equal to plus or minus 5. And then when we add the 4, y is equal to 4 plus or minus 5, which therefore tells us that y is equal to either minus 1 or it's equal to 9. What we know is that y has to be positive because it was equal to x squared, and x squared is always positive. So therefore we have that y can only be equal to 9. Beautiful. Now then, let's replace our y with our x squared again and find the values of x, which give us the boundaries. So, therefore, what we have is that x squared is equal to plus or minus 3 for the square root of 9. So what we have then is these are the boundaries. We know that these two things are going to be equal when x is equal to plus or minus 3. Next thing to do then, we want to find values in between them. So in between minus 3 and plus 3, and then either side to check whether we need to be in between to satisfy or outside to satisfy. So you can think of almost a number line where we have minus 3 and 3. And then either we're going to be allowed inside and not allowed outside, or vice versa. Not allowed inside, but allowed outside. So we'll check all three regions though and make sure it's okay. So you can imagine checking minus 4 here, 0 here, and 4 on this side. So if we check minus 4, when we do 4 squared, we get 16. 16 squared gives us 256. On the right hand side then, 4 squared gives us 16 times by 8 gives us 128. Plus 9 equals to 137. So this is wrong here. This is not allowed. On the right hand side, you can see we're going to get the same values for the 4. The minus just got consumed by the square and the power of 4. So this will be the same. We'll end up with 256 is less than 137, which is not true. So it's not allowed here. If we plug in 0, this side will be 0. Less than 8x squared will also be 0 plus 9. So we end up with 0 is less than 9, which is perfectly fine. So altogether then, we're allowed inside of our two boundary points, and we're not allowed outside. So what we have is that x has to be less than 3 and greater than minus 3, which you could write as the modulus of x has to be less than 3. Beautiful. Thanks very much.